In this video, we are going to explore essential Linux networking tools. These are commands that are crucial for network diagnostics and monitoring. By the end of this video, you'll have a solid understanding of how to use these tools to troubleshoot and manage your network effectively. The 4 tools we will cover in detail are ping, Traceroute, Netstat, and SS. Let's start with the ping command. Ping is a fundamental networking utility. It's used to test the reachability of a host on an Internet Protocol network and to measure the round-trip time for packets. Here are some key points about the ping command. First, it tests if a host is reachable. Second, it measures response time, also known as latency. Third, it uses Internet Control Message Protocol, ICMP, echo request and reply messages to do this. And finally, it helps diagnose network issues. Here are a couple of examples. To use the ping command, type ping followed by the domain name or IP address you want to test. For example, pingexample.com. The output shows the response time from the server. You can also limit the number of pings using the -c option followed by the number of pings. For example, ping --c 3 google.com. This command sends only 3 ping requests to Google. The ping command comes with several options that enhance its functionality. Let's look at some useful ping command options. First, the -c, also known as count, option limits the number of packets sent instead of pinging continuously. For example, $ping -c 5 github.com. This command will send 5 ping packets to github.com and then stop. Next, the -i, also known as interval, option sets the interval between sending each packet in seconds. For example, $ping -i 2 -c 3 cloudflare.com. This command sends 3 pings to Cloudflare, with a 2-second interval between each ping. Another option is the -s, also known as packet size, which specifies the number of data bytes to be sent. For example, $ping -s 1000 -c 2 example.com. This command sends 2 pings to example.com with a packet size of 1000 bytes. And finally, the -w, also known as deadline, option specifies a timeout in seconds after which ping exits. For example, $ping -w 5 -c 10 wikipedia.org. This command pings wikipedia.org, but stops after 5 seconds, even if 10 pings have not been sent. Next, let's explore the Traceroute command. Traceroute tracks the route packets take across an Internet Protocol network from source to destination, showing each hop along the way. Here are some key points about Traceroute. First, it displays the path and transit delays of packets. Second, it identifies routing problems and bottlenecks. Third, it uses the time to live (TTL) field to discover routers. And fourth, it shows the response time for each hop in milliseconds. The diagram here visually represents how Traceroute works, showing the path from your personal computer through various routers, labeled R1, R2, and R3, to a final destination server. Each hop represents a router that the data passes through. Here's an example of the Traceroute command in action. To use Traceroute, simply type Traceroute followed by the domain name or Internet Protocol address you wish to trace. For example, $traceroute google.com. The output lists each hop, along with the response time for each. The Traceroute command also has several useful options to customize its output and behavior. Let's explore some useful Traceroute options. The -n, also known as No Domain Name System Resolution option, shows numeric Internet Protocol addresses only, without attempting to determine host names. This can speed up the process. For example, $traceroute -n github.com. The output will show Internet Protocol addresses instead of domain names for each hop. Next, the -m, also known as max hops, option sets the maximum number of hops, which is the time to live that Traceroute will probe. For example, $traceroute -m 5 cloudflare.com. This limits the trace to a maximum of 5 hops. Another useful option is -w, also known as wait time, which sets the time in seconds to wait for a response to a probe. For example, $traceroute -w -2 example.com. This command waits 2 seconds for a response from each hop. Finally, the -I, also known as Internet Control Message Protocol Mode, option uses Internet Control Message Protocol Echo instead of User Datagram Protocol datagrams. This is useful when User Datagram Protocol is blocked. For example, $traceroute -I wikipedia.org. This forces Traceroute to use Internet Control Message Protocol Echo requests. On some Linux distributions, you might need to use Traceroute or Tracepath, depending on what's installed. Now let's take a look at the Netstat command. Netstat, short for Network Statistics, displays network connections, routing tables, interface statistics, and more. Here are some key points. First, it shows active network connections. Second, it displays listening ports and services. Third, it helps identify network issues. And fourth, it is useful for security auditing. The Netstat command is considered legacy in modern Linux distributions, with SS being the recommended replacement. Here are a couple of examples. To list all listening transmission control protocol ports, use the command $netstat -tln. This will show all transmission control protocol ports that are in a listening state. To show all active connections with process information, use the command $netstat -tunapl. This displays all transmission control protocol and user datagram protocol connections, including the process ID and program name associated with each connection. The Netstat command is packed with options to filter and display network information. Here are some common Netstat options. The -T option displays only transmission control protocol connections. For example, $netstat -T. The -U option displays only user datagram protocol connections. For example, $netstat -U. The -L option shows only listening sockets, which are typically servers. For example, $netstat -L. The -N option shows numerical addresses instead of resolving host names, which can speed up the output. For example, $netstat -N. The -P option shows the process ID and name of the program to which each socket belongs. This requires appropriate permissions. For example, $netstat -P. And the -A option shows both listening and non-listening sockets, giving a comprehensive view of all network activity. For example, $netstat -A. Let's dive into the SS command. The SS, short for Socket Statistics, command is a modern replacement for Netstat, providing detailed information about network sockets. It is often faster and more resource efficient than Netstat. It displays more transmission control protocol and state information. It shows socket internal queue information, and it provides detailed socket statistics. Here's a comparison between Netstat and SS. Netstat is a legacy tool with slower performance and is more widely known. On the other hand, SS is a modern replacement with faster performance and more detailed output. Here are a couple of examples using the SS command. To list all transmission control protocol sockets, use the command $SS -T. This shows all open transmission control protocol connections. To show listening sockets with process information, use the command $SS -TLP. This displays all transmission control protocol listening sockets, along with the associated process. The SS command offers several options for filtering and displaying socket information. Here are some common SS options. The -T option displays only transmission control protocol sockets. For example, $SS -T. This command shows a list of transmission control protocol connections, including the state, receive queue, send queue, local address and port, and peer address and port. The -U option displays only user datagram protocol sockets. For example, $SS -U. This command shows user datagram protocol socket information, including the state, receive queue, send queue, local address and port, and peer address and port. The -L option shows only listening sockets. For example, $SS space -L. This command lists listening sockets providing the state, receive queue, send queue, local address and port, and the associated process. The -P option shows the process using the socket. For example, $SS space -P. This command shows the processes associated with each socket. The -N option does not resolve service names, displaying numerical addresses instead. For example, $SS space -N. This shows addresses and ports numerically, rather than symbolically. The -I option shows internal transmission control protocol information. For example, $SS space -TI. This option provides detailed transmission control protocol information, such as qubit congestion control algorithm settings, window scale, and round-trip time. Let's summarize the Linux networking tools we've covered in this video. First is ping, which tests connectivity between hosts and measures round-trip time. Use it to verify basic network connectivity, measure network latency, and test domain name system resolution. Next is Traceroute, which traces the path packets take to reach a destination. Use it to identify routing problems, locate network bottlenecks, and understand network topology. Then there's Netstat, which displays network connections, routing tables, and interface statistics. Use it to view active connections, check listening ports, and monitor network statistics. And finally, SS, which is a modern replacement for Netstat with more detailed socket information. Use it for faster socket statistics, detailed transmission control protocol state information, and advanced network troubleshooting. These essential networking tools help Linux administrators diagnose connectivity issues, monitor network traffic, and troubleshoot complex networking problems efficiently. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.